Gentlemen, welcome to my mess of a mess of a desk. Mess at the desk. Just wanted to do a quick video talking about some troubles I had with my closed loop cooler here, AIO, whatever you want to call it. What to do, what not to do when you take these things apart, how you should service them, how not to service them. As well as some other random wow, I really can't speak today. Tangenty bits, such as how to power them when they're outside of your case, or why there's duct tape on my graphics card, and other silly things like that. But anywho, every story's got to start somewhere. So here we have my Asus M5A97R 2.0. It's got an FX8320 on it, 16 gigabytes of Corsair Vengeance, 1600 megahertz, CAS latency 9. I know a lot of you are probably rolling your eyes. 8320 and a 970 chipset is no bueno. This is only a 4+2 power phase, so it's only designed for 95 watts, but through a BIOS update it supports 125 watts, which is what this chip is. I ran it at 4.3 gigahertz, all cores all day, so for many days, like 10 hours a day plus. So I mean, the board took it. Nothing failed. The RAM's fine, North Bridge is fine, power phasing's fine. This got actually quite toasty. I ran the base clock at 265 for quite a while there, and that made the memory go up to like 1750 or something like that. And yeah, it took it all just fine. So this board was great for a long time. The problem was I couldn't get into BIOS. When I pressed delete, it would go to a black screen, and I couldn't do anything. It would like lock up. And this board has a direct key. Press that when the system's off. No input required. It'll go straight to the BIOS after it posts. So that didn't work. Memory okay over here. That button does a quick test of the RAM and then forces you to press F1 to enter the BIOS. That didn't work. Black screen. Eventually I had the wise idea to pull the CMOS battery because hell, I'm smarter than a motherboard, right? Well, for some reason on a 2010 motherboard, or 2011, something like that, the default standard for communication with the hard drives is IDE. And when I pulled the CMOS battery, my Windows 7 AHCI installation really didn't like that. And now I had a board that could no longer go to BIOS, and I couldn't go to Windows either to change the setting because it's, of course, in the BIOS. So I got boned. I faffed around with this for a day and a half. I tried flashing the BIOS many times, which was weird. It was successful. The board would post, and I could like select an alternate boot device, but that doesn't really help if the boot device doesn't support IDE or something like that, right? So I eventually just caved and got myself a 3600X with a Tomahawk Max B450 and 32 gigabytes of 3200 CAS latency 14 memory. This was very nice memory. And then I just bought an AM4 adapter for the Asetek pump that came in this Corsair H100IV2, I believe. But yeah, so I mounted this onto here, did some overclocking and some benchmarks and shit, did a few Cinebenches, showed the results to my buddy who also owns a 3600, and he said I had some core temperatures that were going above 80 degrees, and he said that's no good because these stock coolers at stock settings should be able to keep these 3600Xs below 80 degrees C at stock. And so my water cooler was actually performing worse than my air cooler, which you think I would have noticed when it was mounted to the FX. But this guy was overclocked all day, so I kind of just took the high temperatures for granted. I mean, it idled at 30-ish degrees Celsius, and under load never really broke 35. But I did have these really nice, these are the Noctua industrial 3000 RPM variants fans, because the more noise something makes, the more powerful it is, obviously. I mean, trains, boats, planes, cars, it's all the same. PCs too. But yeah, these fans really compensated for the lack of performance I was getting out of the actual water cooler itself, or at least to an extent. But I really didn't notice it until I got it onto this board. Um, so owning, a screwdriver set and a pair of balls, I decided that was a license to open this thing up and see if I could fix it. And it went okay for the most part. I took it apart, drained all the coolant out, and flushed it several times, flushed it 3 or 4 times before filling it back up, reattaching the cold plate. Actually, before I reattach the cold plate, I'll actually show you. This is the cold plate now, and I do have a before and after image that I'll put in the video here somewhere. But this is the cold plate. I cleaned it up using one of these. This is a dollar store paintbrush. This thing is awesome. These bristles are just the right diameter to fit in the micro fins that make up the cold plate. Literally, dollar store artist brush set, $3. Got a whole pack of them. But that worked perfect. I tried using isopropyl to try and break up the gunk that was in here. That didn't work. I then moved on to vinegar or acetic acid for you chemist nerds. That didn't work. It didn't touch the copper at all and didn't touch the schmoo that was in there. So I went on to some tub and tile cleaner, and that actually worked well. That managed to break the stuff off the, or at least dissolve some of it, soften it up so I could get it off the cold plate without actually damaging the cold plate. So once you get that mounted and you get this thing flushed and filled, you have to run it out of the machine and use this bleed port. Bleeding it is kind of simple. You just, you got to power the pump on, and with it filled, and bring the pump higher, make the pump and the bleed port, the highest point in the loop. I'll show you the bleed port. You can see the red through it right there, right to the right of my thumb. That's the air bleed. There's normally a screw and a rubber washer that sits in there. But yeah, you turn the pump on, bring it up high, air all bleeds out, and you'll hear it when the pump... Actually, you won't hear it. The pump, when it's pumping water, is at its quietest. If it's pumping anything else, either air or if there's other material in the loop, you'll hear it, which brings me to the next problem. So once I had this thing bled and filled, I put this cap back in here, or the screw back in here with the rubber grommet, and while it was still running, I picked up the whole thing and just gave it, a wiggle around to make sure that there was no air left in it. But unfortunately, when I did that, there was still some debris in the radiator, and it made its way down to the pump and jammed up the pump. I heard it just stop, and when you're holding this and it's not mounted to a PC, you can feel it when the pump stops. Just like any CPU fan, if you get your dilly or your finger stuck in it, the fan's going to stop, and as a protection thing, it's not going to start the fan again, or at least it's not going to try to start the fan for a few seconds to give the obstruction a chance to clear, and then it starts the fan. Same thing happens with your Ace-Tech pump. To protect the pump, the thing has to stop if it gets jammed. And I heard some grinding noises and shit in there too, so I figured, oh great. Now I've really bunged up because I have the pump back together, and now the pump is grinding, and I've got crap in there still. And that's when the story went south. This is actually a tale of success and then failure. I actually had the pump all together and working until I moved it and dislodged some crap that was in the radiator that I didn't clean out. And I had to take it apart again, and that's what killed me. Because the first time, this is where we move on to the what you could have done better than I part of this video. The first time, you can see the problem here. This screw is just stripped right out. There's no salvaging it. It's too tiny. It's not enough sticking out to get a pair of pliers on it, and good luck getting an easy out that small or something, and even then you need to find a replacement screw. So this $120 unit is now, pretty well almost garbage because of a 2-cent screw. But regardless, Yeah, do not strip out these screws. There, you have a very high chance of doing that, especially with this Corsair cooler. The screws are made out of literally Play-Doh. Like, I don't know how they don't end up chucking out 3 out of 10 of these things at the factory just by trying to assemble them with those screws. Not to mention trying to get them out of there. But regardless, because I had to take it apart the second time, I stripped out the screws. I actually stripped out 2 of them. The other one I actually managed to get out using the rubber band trick. But yeah, so that's one thing is, one I would wholly recommend is holding on to this Ace-Tech bracket. Leave your bracket on the pump and use it as a way to brace the pump when you're screwing or unscrewing any part of it. You can also, I would highly recommend bracing the pump against something when you screw it using the bracket. And that way, you know, if you're really smart, you'd build a little jig in your vise for this. And that way, you know, you could just both hands focused on the screwdriver so you do not strip those screws. The second thing I would say when you're taking one of these apart is just go real slow, because, you know, every step of this process, I walked into this thinking, knowing that this would be 2 to 3 hours, but I ended up spending the majority of the night last night just slowly trying to take this thing apart. And I ended up stripping those screws after realizing rather quickly that they were quite strippable. You know, I took my time and I was very delicate, but I'm just in my apartment. I don't have a vise or, you know, any extra hardware to screw this thing down and make it secure before I try and take those screws out. So if you can do anything to do that when you service one of these, that will really go a long way in making sure you get this right. Because as I figured, even when I screwed up, I got it right the first time. You can take, at least in my case, I can take one of these apart once and put it back together again once. If you have to take it apart again, you know, like, that's a stretch. That's a stretch about how it's, whether or not it's going to go well or not. These things, you know, they say they have a lifespan of 5 years. This unit is actually only 3.5. I think 5 years is actually rather an over-exaggeration. It's not correct. I would say, like, the only case you would get 5 years in a cooling system, any sort of closed-loop cooling system, it would be a car, where you have a known formulation of coolant for a known mix of metals that comprise the coolant system. For example, like, cars are going to have copper, nickel, magnesium, aluminum, iron. They're going to have all sorts of stuff that can galvanically interact with each other inside the cooling system, and you need to have a very resistive formula that's ideally OEM and designed for that cooling system, instead of just a blanket all coolant, which is something like this would use. You know, a cover all your bases sort of general specification, get it at the gas station, that'll, you know, top you up until you get back into town sort of thing. Which also I should note, the coolant in these things, if they're old, they stink to high hell. Holy hell. Man, that was not a pleasant... I've smelled a lot of car coolant in my life. Old car coolant, 25 years old, did not smell like that. This thing stunk. Probably because it does not get hot enough. Like, a car engine will reach 90 degrees C and kill anything organic inside of it, so you don't really need any sort of biocide in an engine. In a closed loop cooler like this, where you're reaching, you know, 35 degrees, 40 degrees, that's the optimal temperature for bacterial growth. So you need a biocide in one or in your cooler of some sort. But yeah, to say these things last 5 years, no, I'd say you get 2 years of good performance, a year of back to air cooler like performance, and then anything beyond that, you know, is either you're a lucky break or it's a stretch, because, like, even, you know, the Lictech TR4s, the Lictech 2s by Enermax, those have been huge in the news recently because of how big a pieces of crap they are, because they just their formula didn't account for galvanic corrosion at all, it seems, because the things just fill up with shmoo within a year. And so that's just one thing you want to be aware of. Like, if you own a CLC, you're going to have to take it apart at some point if you don't want to replace it. A lot of the times it's, I think that's their business formula too, is, as long as it's easier to spend $100 and get a new cooler than it is to take the thing apart, well, that's just good business. In this thing's case, it was worth about $100 to me, but if you can save a nickel somewhere, why not try? But with this guy's case, I mean, it is still salvageable, provided I could get that screw out of there. Maybe I could get another screw for it. But that'll be something I'll have to attempt at a later date. You definitely want to be very careful when you take one of these apart. And especially when you put it back together again. Like I said, I got away with it once, but I did not get away with it the second time. As for powering this thing and testing it out of the bench, that's actually really quite simple. So at least in my case, it's simple because I have a 12-volt fan controller up front here. That's just a touchscreen display on it. And this is a power lead going to the 12-volt connector on the pump itself. Powering something off your power supply like that, it's quite simple. You just need to disconnect the ATX 24-pin power from the motherboard. You need to disconnect the CPU power. Basically disconnect anything you don't want powered while doing this. In my case, I'm leaving my hard drives plugged in and my SSDs because they're going to get power, but they're not going to do anything anyway if they don't get any signal from the motherboard, so we'll be alright there. In terms of this guy, I'm going to have to put my phone down to show you how this works. I'm going to do right here without a cable in the way. Perfect. Okay, so here we have our ATX 24-pin connector. I'm working in the camera here. The green and the black cable are shorted together to tell the power supply to turn on, and they're continuously shorted. So now if you listen very carefully, when I short these two connectors, and like that, you can hear things powering up. And I'm just going to hold on to that because that's just a pair of tweezers hanging out there. You can see that pump has turned on. The LED is lit up. That fan is turning. And put the phone down, grab the tweezers. You hear the system shut down. Fans turn off. LED is off. And that's just how you run that pump. In my case, I only ran it for a short time just because I do not want to burn out this pump. If you run a pump dry without any fluid in it for too long, they will burn out. They're designed to be lubricated and cooled by the water, so don't do it for too long. But that's how you do that. It's really simple, and it's an excellent way to bleed the system of air and bleed it with confidence because you don't have a reservoir or anything or any bleed port or anything like that. And yeah, that basically covers that. Don't, just all in all, be careful. Don't go too ham trying to take one of these things apart. If you 200-pound gorilla it, you will ruin it. Absolutely. But it can be done. It can be serviced by the end user. You just got to go slow. Probably have some good tools and take your time. Yeah, that's my little warning for you guys, as well as my story of failure, and hopefully some of you can glean some success from that in the future if you ever have to take one of these apart. I know if anyone owns an H100IV2, these things aren't in production anymore and they're all reaching their end of lifespan. So someone's probably wondering how to take this thing apart. So if you got any questions, just leave it in the comments below and I'll do my best to get to you. Thanks for watching and have a great day.